Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome again to another episode of the Smart City podcast. Today, I'm thrilled to be joined by Allan Gray of sunETrike in the Philippines. Welcome, Allan.
Hey, good evening.
Hey, good morning to you. So you've got a very broad experience across the world. Can you tell us a little bit about how you came to the sustainability world in general and e-trikes and energy efficiency and conservation in particular?
Yeah, sure. So I grew up in a small logging and mining town called Prince George, about kind of right in the center of British Columbia, Canada. And it was, so when I was going through high school, I watched the mountain pine beetle go through the forest. So I don't know if how many of our listeners would be familiar with the mountain pine beetle, but it was one of the very early kind of like pretty obviously impacted by the climate. Like the fact that the climate was not getting as cold caused this beetle infestation that would normally kind of run its natural course, basically spread through the whole forest and wipe out even very like not the old, like generally it was a pest that would get the old and the sick trees of the forest. But because it has this natural antifreeze in its shell that did not get killed off by the winters, which weren't getting as cold anymore, it was able to spread and spread and spread and just really do a very substantial economic damage. And I watched, as like in high school, I watched entire forests go red in 1 year and then dead, like completely bone dry dead the next year.
Wow.
The really serious forest fires that have happened over the last 5 years, I know California's had them, but BC's really had them as well. And that's just because all of this dead standing timber has been just sitting there and drying out over the years. And so we're seeing the consequences of that through to 2019 was 2018, 2019 were especially bad years for forest fires. So that was very formational for me. And my father he used to run an ISP, an internet service provider in that area. And we would go to very remote towns and fishing resorts and native reserves and bring internet to those communities for the first time. And I put my first solar panel up on the side of a Radio Shack on top of a mountain in high school. So that was my experience. That was back when solar was like $3.50, $4 a watt in like 2003. So totally off grid. With our SCADA system, we would see the sun pop up and pop back down again for a few hours, like maybe 4 or 5 hours, and that would be what would keep the radio station running through the winter.
That's fascinating. So how did you make your way to the Philippines?
Well, I was like with this, having seen this, I went through university and kind of developed the desire to apply my career towards energy conservation. And I started out in engineering. And was thinking about how might I apply this towards a very resource focused. I was in mining engineering, but then I switched over to geology. So starting in engineering and moving more into pure science, very natural resource focused, and geothermal seemed like the most obvious fit for that path in order to be like a clean energy specialist, technician at a scientific or an engineering level. And yeah, so geothermal, but Canada doesn't have a geothermal industry to speak of when you're talking about like high grade power. You've got heat pumps and stuff like that. But all of the volcanoes in Canada are hundreds and hundreds of kilometers away. So as a kind of a student of the world, a geologist and a knower of the earth, I was paying attention to countries like the Philippines and Turkey for many years, kind of during my degree and post-degree. And my father moved to Hong Kong in, I guess, maybe around 2012-ish. And so he, I mean, as an entrepreneur, he's always kind of coming up with new ideas. For the most part, I didn't really have much to say about it. But when he proposed solar electric tricycles in the Philippines to me, as soon as I heard it, I just said yes. I mean, it caught him by surprise even, but we kind of started putting the model together. And in 2015, we arrived, the end of 2015. And got to work building. We got our first pilot project shuttle service running in 2016, serving a private subdivision that was under construction at the time. And so we were operating 16 to 18 hours a day, 365 days a year. We had 4 tricycles, just driving people in and out of the subdivision for 10 pesos, which is about 20 cents US per ride per person. We had, I think, around 3N uptime, so 99.999% uptime versus the service contract. But that proceeded until December 2020. We were doing the whole fundraising and trying to get in and figure out how we were going to get our business model funded. And then, of course, the pandemic hit. Well, not just a pandemic. The Taal volcano, which hadn't erupted since the 70s, erupted in January of 2020, which was, as a geologist and like a volcano-oriented electrical geophysicist, was just one of the most amazing things to witness. And then right into pandemic. It's considered one of the most dangerous volcanoes in the world. So knock on wood, it was actually there were not serious casualties or anything. Like, I think there was maybe one person passed away, but our entire family swam in the lake that erupted about 10 days before the eruption. Was quite something to watch in retrospect.
Wow. So what's the current status of your projects? What needs are you trying to address? Just outline your business case around what's happening there.
Right. So, I mean, the Philippines is an island archipelago. They've got several thousand islands. And so they are kind of distributed energy is sort of forced on them by their geology. We're not in a super remote area at this time. The city that I live in is about 500,000 people. And there are many cities, like kind of small cities of similar size scattered around. And we're kind of on the periphery of Manila, which is, of course, a mega city. But if you get, even on this island, not very far from me, you can get energy prices that are not that different from fly-in remote communities in the Arctic, like in Canada. So like you're talking about like more than $1 per kilowatt hour, which I mean, it kind of blew my mind to know that. And that's not even getting into small islands. So an electric vehicle transition towards, like the transition towards electric vehicles, this is a place where solar is going to compete very well as long as the infrastructure is built well and robustly. And of course, the supply chain issues are very challenging. But I mean, that's the long-term value proposition for me as a geologist, for why would you try to push, like, I guess, become a champion of solar-based transportation in a country like the Philippines compared to other countries like maybe Thailand or India, which are, of course, on the continent. So you just got the much more like megalithic or monolithic like energy utility. In the Philippines, you've got hundreds of small energy cooperatives. And there's a lot of studies in the United States that talk about how the electric cooperatives have a much higher rate of uptake of solar technologies compared to the more commercially built grid utility companies.
No, indeed, the investor-owned utilities have different cost accounting than those that are simply buying power from an IOU. Or from this government-owned grid. You've undertaken a bit of a heavy lift, as it's not only an electric vehicle, but it's also a charging mechanism, and it's a charging mechanism driven by PV. Do you want to touch on perhaps each one of those?
Okay, so I mean, the electric vehicle is it's a tuk-tuk. If you're familiar with the term tuk-tuk, they're these small three-wheeled vehicles.
Right.
And as you pointed out, if you're going to do that with electric, you got to charge it, and so you're relying on the grid primarily. And where we had our shuttles, our pilot project, we had a very stable grid, and not excessive energy prices. So I think we, in the entire time of 2015 until 2020, 2016 to 2020, we only had one power outage, and it was because somebody hit the power lines with a kite. So like that was very good reliability during our time there. We actually, not knowing how long the power outage would go on for, we were actually suggesting to the residents that we could take our tuk-tuks around and power freezers if there was anybody who had the concern that their food might go bad, like people who are running small restaurants and stuff. We were in a position to be able to offer them battery backup. And then the solar, we had the solar that we were able to put up in our pilot project for that time. When we initially started, it was a fallback, so it was a grid tied solar system. So we weren't relying on the solar for our pilot project in this case because the grid was reliable. But when we initially put it up, it was probably covering about 70% of the daily usage. But because it was a growing subdivision, the requirements of the vehicles increased faster than we were able to get new roof space. So by the end of it, it was probably about 30%. And of course, if we were to extend that into less reliable places, we would have to move more towards an off-grid style topology for that. But that just hasn't happened yet. As I mentioned, we kind of needed, obviously solar and electric vehicles it's a very capital intensive operation. And we just weren't able to get that rolling on the financial side before the pandemic.
Yeah, Allan, I have two points. One is that even in the developed world, we're starting to see here in the United States where commercial or government bus operations are there are a number that are now PV powered electric bus depots. Because the cost of building a new substation and running the power to that new substation for charging is a significant number, that actually a microgrid with PV panels makes a better financial business case. I've also read quite a bit about the impacts of electric vehicles as mobile battery backup. And in particular, in some less developed countries, India comes to mind, that mobile battery backup can drive the factory or the machines in the assembly plant so that a tremendous amount of economic activity is not lost for the day. So it's not just the creature comforts of having lighting to prepare dinner or a light for kids' homework, but it's actually, well, if you don't have the power in many places in the world, people just go home and come back when the power's on and go back to work all over again. So it's, that is fascinating to me, and I think can make a dramatic, impact. So what are where are you now in your development plans for the sunETrike? How many vehicles do you have out there, or how many? What does the footprint look like?
We actually don't have vehicles running right now. With our small team, when the pandemic happened, we kind of concentrated our efforts on, my father lives in Hong Kong, so I'm the only one in the Philippines anymore. My brother was with me here from 2015 until 2020, but it's just me now. But my father has always been in Hong Kong, and we were able to get into the Hong Kong Science and Technologies Park's incubation program for a supercapacitor module that we're building, with the intention of putting that supercapacitor into the electric vehicles, sort of as a filtering function, like a hybrid. It's called a hybrid energy storage system. So you got the battery and the supercapacitor in parallel. Sort of you talk about peak shaving at the grid scale. Well, this is peak shaving at the electric motor surge current scale, sort of filtering function, and so it's expected, and we don't have good data on this, especially with lithium batteries. It's still kind of been elusive to get good data to quantify how much it's expected to make a difference, but reducing the surge current just from a basic electrical strain perspective is expected to increase the battery lifespan, as well as the range per charge, using logic similar to the Pucher effect. If you're familiar with that in lead acid batteries will have a different capacity depending on the average discharge current.
Correct. I know you're involved in a variety of technologies. That happens to be two. What other things do you touch in the world of energy?
So another project that the Hong Kong side has gotten involved with is in collaboration with a quantum information and energy harvesting research group operating more at the theoretical physics level, and so we're kind of filling the role of commercial partner for this project, which is basically taking the suspension system and creating a transducer that you could basically produce electricity from, which of course has been tried in all sorts of ways in the past. So what our little angle is on that is to have basically variable damping using machine learning, with the possibility of moving into like a quantum situation in the future. I mean, we're not there right now, but the idea of being able to do variable damping in order to increase comfort and, of course, yield more energy out of the vibrational the vibrations that are coming out of the road. So you're trying to keep the road, the passenger comfort, like the experience for the passenger stable. And of course, your road is going to have all sorts of impulses that are available. I mean, of course, a leaf spring's not going to do anything, but if you're able to put that damper in there and produce electricity, then that's
a fascinating application. It is an evolution of regenerative braking.
Right.
In my mind, it's linear braking rather than rotary braking.
Yeah. And I don't know how much the electric, I don't know what the status of like the top tier automotive makers is right now, but a lot of even with lithium batteries, it's more so with lead acid, but even with lithium batteries, they keep their regenerative braking settings turned down because they don't want to be feeding too much current into the batteries. So that's loss. That's loss on the system. I'll just let these dogs finish off and continue.
No, that's fine.
The point is that supercapacitors should be able to handle the supercapacitors are inherently able to handle that high current better than batteries. So,
well, and certainly we know that electric, particularly the more popular commercial electric passenger vehicles today, have limitations on their discharge cycles, where you really you cannot deploy some of our visions of vehicle to grid, applications. That holy grail of, say, charging my vehicle at night and doing some arbitrage and selling my power at 3 p.m. to power my air conditioner, can't really happen on a daily basis today because of battery life issues and the impacts of hitting that battery too hard every day. That's fascinating. So which of the variety of technologies that you're working with are closest to commercialization, and what obstacles do you see in actually getting them into the market?
We hope that we're going to have the supercapacitors in the vehicles in the coming months. I mean, they'll be in vehicles that we've got a pretty close eye on. We wouldn't be trying to put them out into vehicles that kind of like open market situation requires a higher level of engineering. But in our case, in our shuttle service previously, the vehicles were running on the same roads every day, and we were on site all the time. So that's kind of like the expected initial test deployments, and that was sort of expected to be the benefit. I hope that we'll have an opportunity to deploy our vehicles again in the coming months. But the other issue was that we never managed to get through the whole government registration process. It's hard to say. It's hard to say how we'll mitigate that whole process. There are a lot of electric vehicles in this country or makers in this country that don't really worry about the whole registration thing. You could probably imagine. But coming from North America, that's the sort of thing that I've kind of got a certain amount of conviction about. It's complicated. There's a lot to say about that topic.
It's only recently here in terms of autonomous vehicles, electric vehicles, Florida is one of the faster moving states. And it only was 2 or 3 years ago that legislation was signed into law where a 3-wheel vehicle now does not require a motorcycle driver's license.
Oh, okay.
Because we do have some very, very engaged, energy and environmental activists who are lobbyists who simply looked at the delivery service of, not so much Amazon, but Instacart for food or the pizza delivery person. And why are they driving a 4,000-pound car today or a 6,000-pound electric vehicle when those deliveries are only a few miles and they could much more easily be served by a 3-wheel 1,300-pound vehicle?
Yeah, totally. Yeah,
that's less road wear, and there's an awful lot of just related benefits. And there, we, here in North America, as you know, Al, we don't see very many 3-wheel vehicles, but that industry is on the rise here, particularly in Florida, because now it's you don't need a license, which is you just register it like a regular car.
Can I ask a question regarding?
Florida also has taken a lead that you don't need any extra insurance for an autonomous vehicle.
Oh, wow.
Yeah. So there aren't a lot of those yet, but there's no the impetus there was to make sure there wasn't any extra overhead to that industry, regulatory overhead that caused it to be held back, which is pretty fascinating.
Okay.
So
Sounded like
go ahead.
Yeah, sorry about that, guys. I just wanted to ask you about installing solar panels in the Philippines and regarding monsoons and the weather because of the summer months and the heavy rains. Was there any special processes or like special requirements for the roofs that you actually place the solar panels on?
Well, I mean, we worked with the building engineers to review our own design, and then we did the fabrication. We put it up in coordination with the people who were because there was active construction going on those houses anyway. We were able to coordinate with both the building engineers and the people that were doing the actual building, and come up with a solution that did withstand a few typhoons before we vacated the premises.
Well, Gavin, thanks for that question because it reminds me that Gavin and I both live here in South Florida, and in 1992, Hurricane Andrew impacted south of Miami and caused a variety of huge impacts to the building codes here. And I think what Gavin might be referencing is that the Miami-Dade rules require a 150 mile an hour rating for any new construction. So that's windows, that's doors. There's some great videos on the internet about how they test that with a baseball pitching machine and putting a 2x4 in it and shooting it at the window.
Oh, wow.
But one of the impediments to the solar industry here in Palm Beach County, Gavin's in Broward, and Southwest is Miami-Dade, is all of that infrastructure for that solar panel must be rated to 150 in Miami-Dade and I believe 140 in Broward, and that's it's an impediment. But it is what it is. We live in hurricane territory, and I know that the Philippines gets impacted as well.
Yeah, they certainly do. I mean, I take my when I'm going and doing wind studies, I'm largely pulling my information out of Western sources, and then I work with the industry practitioners here. But if we were to go and try and look for somebody who is going to do an inspector that would render a judgment about whether something was rated for like 100 kilometers or 200 kilometer winds, we wouldn't be able to find them, and you just get blank look from the industry. Like we just like the industry doesn't have that level of sophistication around here. But I mean, people grew up with these kinds of winds, and so the engineers are attentive to it. And in a lot of cases, like if you were to try and put on factories, a lot of factories have not built their facilities with the idea that you would be putting a ton of solar panels on the roof in the first place. So there are a lot of buildings that are disqualified from putting loading on even before you think about putting even before you start thinking about wind. And so there's a lot of considerations, and then there are a lot of building owners who would not want the building the roof penetrated, and then the whole insurance industry and what's their level of comfort with that. I'm not active in the solar industry directly at this. Like I haven't been going around and trying to propose to different places to do it. It's like because really my mission here is more on public transportation. So I like trying to go and get really into like building requirements and stuff. I work with engineers when there is engineering design considerations that are outside of what I can sign off on.
So your active day-to-day efforts are about public transportation using electric vehicles.
Right. Yeah. That's kind of the niche side that I've been in. I'm not really looking to sell this into personal, like the personal vehicle market. And so the public transportation is here is quite different. And tricycles they're actually motorcycles with sidecars here is the more common way that tricycles are run. And that is a very common public transportation vehicle here, and it's done through the city. This might be a nice segue into the whole IEEE P2784 bit, because this is where the smart cities side of things comes in, and why I've taken special.
So explain that to our listeners, Allan. Some governmental entity actually owns motorcycles with sidecars, and you pay a fee to be transported around the city, or how does that work?
No, you have these member associations. Who specifically owns the tricycles? It might be that the mayor owns a number of tricycles that are in these associations, but tricycles that become part of these associations must register with the city, and each of the cities have their own tricycle kind of regulatory body and licensing body that gives them the permit to be a personal carrier. A member of public convenience is a label they use it.
Okay, so it's what comes to mind is sort of the yellow cab model from yesteryear.
Yeah, you could say that.
So they're privately owned, publicly licensed. Who drives them? Is it rented like an e-bike, or how does that work?
Well, I'll just qualify that there's. You do have taxis in the mega city, but you don't really have even a city of this size, this close to the city. I very rarely see a taxi, and if I see one, it came from Manila.
Right.
So you could say that it is the same, but tricycles have less range. They don't move around as much as a yellow cab would. They generally they have their main corner off of the main road, and they'll service an area off of that kind of main artery. They'll service the area that is around that. So that's kind of, they've got their little zones. So you might have 20 or 30 tricycle associations that have their own little lineups or territories within a single city of this size. It's common. Every TOTA is going to be different. TOTA is Tricycle Operator and Drivers Association. But it's not uncommon for it to be about 50-50, where you have 50% are independent owner operators and 50% will pay a daily fee to whoever owns the tricycle to drive.
Okay. So I'm intuiting that one of your goals is to electrify those vehicles.
Yeah, and get solar up on their terminals.
Beautiful. What's been the perspective of all the different stakeholders in those communities about this?
I think they admire electric vehicles, but when you put a price tag in front of them, they get pretty nervous. A lot of these people are living day to day, like food, hand to mouth income. And of course, you've got medical emergencies and stuff like that can be devastating for a person in that economic condition. So the idea that you're going to buy a new vehicle, let alone electric, is pretty scary for them. We've found an inventor of a device here in the Philippines. He's an American guy, but he's been in the Philippines for about 10 years. And he's developed a device that you can put between the carburetor and the motor into that intake manifold there, that via fluid dynamics and sort of it's basically a ring with fins that causes the air fuel mixture to be more like thoroughly mixed, which gives them about 20% improvement in fuel efficiency by the numbers that we have right now. The data is not that well constrained, but they're getting about 20% efficiency gain, and at a return on investment that's like in the hundreds of percent. So
and less carbon emissions.
Correct. Yep. Yeah, it's. I mean, according to I was skeptical about this claim at first, but the U.S. EPA actually verified it for me. That you can basically take the carbon content of a liter of gas and gasoline and extract the carbon dioxide emissions out of it, irrespective of the type of motor that you're using. I was surprised by that, but the U.S. EPA confirmed that's a valid way to calculate dioxide emissions.
Well, Allan, this has been a fascinating conversation. My last question really is, what across all these different technologies that you touch, what do you see for the future for the Philippines and maybe Hong Kong and elsewhere?
Well, I mean, electrification is definitely coming, and I mean, as a geologist, the battery supply chain is something that I definitely try to follow in so much as I can. I mean, a small company like us doesn't really have the ability to influence how that plays out,
right?
But definitely, the battery supply chain is going to have a huge impact on that. And the fact that those resources are concentrated in such few countries is kind of a little bit scary from the perspective of that whole resource curse that happened with oil and gas, and like how the Middle East became a real powder keg. And so how would that impact places like Latin America with the lithium and Morocco with the phosphates? Of course, cobalt is notorious for that anyway already.
Right.
So I mean, I kind of hope and pray that we'll be able to handle that whole dynamic better than it played out last century with oil. Yeah, because I do think that the technology is in a position to deliver what people are hoping it will deliver when it comes to better carbon footprints and for everybody, and of course, the more efficient you can be, the more supercapacitors and the more onboard harvesting you can do with solar panels and vibration, that will help to improve and leave a smaller footprint per kilometer that you go. I think all of those can play their role, but at the end of the day, you are still pulling a lot of metal out of the ground to build a battery.
Certainly. Well, Allan, I'm looking at our clock and we're just about out of time. Is there any last words you have for our audience today?
Well, I mean, Jim and I know each other from IEEE P2784. So that's where smart city, I guess, enthusiasts and planners, that's where we're hoping to be able to provide some high level guidance on how to go about planning and sorting through the maze of different technologies and approaches and solutions that a smart city can offer. So if you want to check out P2784, that's a place where I'm going to be during 2023 at least, online. And yeah, I think.
Well, that's great, Allan. Yeah, for our listening audience. The IEEE P2784 initiative was started a few years ago, and it really is intended to be a smart city cookbook or a flow chart of what you can do to make major impacts with a strong financial business case. What do you do if you're a city manager or a citizen activist or a mom or dad at the Parent Teacher Association? So that effort's been underway for a while. It was dormant for a few months, but I know has been restarted under Kishore Narang. I would urge everyone to participate. For a period there, I was the chair, so I have some investment in it. I know Allan was an active member as well. So that's a plug for the IEEE. Allan, before we go, would you be kind enough to share some contact information if anyone would like to reach out to you?
Yeah, sure. So our website is sunETrike.com. So SUNETrike, TRIKE, trike.com. And then my name is Allan.Gray, so ALLANGRAY at sunETrike.com.
Well, once again, our guest today has been Allan Gray of sunETrike. Allan, thank you very much for spending your time with us today. Thank you, Gavin, for being on here as well. And we look forward to seeing you on another episode of the Smart City Podcast. Thank you very much, everybody.
Broadcasting from Boston, Massachusetts, the Smart Cities Podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City Practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.